Welcome to Unit 2, Lesson 3. Today we're going to use some models to visualize decimals. You're going to need to be on page 43 of your student activity book, and let's get started. Be prepared. I'm going to be asking you to do a lot of things before I do them. I will show you how to do them, but I need you to try them first, so pause the video when asked, attempt to try to solve the problem on your own, and then come back and see how it's done. Question number 1. Here we have a giant fraction bar. We've seen these fraction bars before, and we can see that this fraction bar, as it says here, is equal to 1. So the entire fraction bar is equal to 1. You can think of that as a granola bar or a rectangular pizza. You can also see that the fraction bar is cut into a lot of equal pieces, and you can tell that it's cut into equal pieces with these dark lines here, and each one looks to be equal pieces. So we can count these equal pieces in here as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these blocks is going to be worth then 1/10. So we could label that if we wanted to, 1/10. 1/10 for each one of these. I'm not going to label them all, but you can see that each of those would be equal to 1/10. But we can also see that each tenth is broken up into smaller but equal units, and within each tenth is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces as well. So while this pizza or this granola bar is broken into 10 equal pieces, each piece was then broken into an additional 10 equal and very much smaller pieces. And so the total number of pieces, if you're counting the smaller ones, would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we have a rectangular bar broken into tenths and also broken up into 1/100ths. Each of those smaller pieces is equal to 1/100th. Now they're asking you on part A here to shade 6/10ths of this entire bar, and then when you're done, shade 2/100ths more. Now I'd like you to pause the video and do that, and then come back and see how I do it. Okay, welcome back, and now I'm going to show you what you should have done. Hopefully you did this. We're going to shade 6/10ths, which would be 6 of these large areas. There's 2, 3, 4, 5, 6. And then we were asked to shade an additional 2/100ths. And the 2/100ths are the smaller ones. So I'm going to shade 2 of my hundredths. I'm going to just use a different color for that. This would be 2/100ths shaded. Now part B is a discussion question, and it's asking you why this drawing up here is showing 6/10ths plus 2/100ths is the same as 60/100ths plus 2/100ths, which equals 62/100ths. Now I'd like you to pause the video and take a minute to think about why this is true and how we demonstrated that up here. And I'll be asking for your input when this lesson is over. Number 2 is using a number line. It's labeled in tenths, and it's going to be used for parts A and B here. But I don't want you to think of this number line as anything different than what we just did. This is really the granola bar above, or the pizza above, which was cut into 10 equal pieces. So is this one cut into 10 equal pieces, exactly the same way as the one we did previously. The only difference between the number line and the previous fraction bar is that this number line is not cut into also 100 pieces as the previous question was. But that doesn't mean that we can't do that ourselves. There's plenty of space in between that we could cut this into 10 equal spaces to make it just like the last one. I'm not going to do that right now, but just something to think about as we go through this problem. Part A, or question A, says begin at 0 and circle a distance to show 28/100ths. Well, again, this is not broken into hundredths. However, we just displayed that we could break it into hundreds, so I want you to imagine where 28 hundredths would be, and draw a circle. Just draw a circle starting at 0 until you get to 28 hundredths. And pause the video now and do that, and then come back for the rest of the lesson. Welcome back, and you should have started 0 and circled or drew your line all the way till you got to what you thought was about 28 hundredths, which should be less than decimal 3 or 3/10. It's 28 hundredths. So if to get 28 hundredths, if we broke each of these into 10 equal parts as well, that would be 10, and this would be 20. 2/10 is worth 20, and then we would need 8 more. So it's going to be a little bit less than 30, so it should show up somewhere right around here. This is where you should have drawn it. If you didn't draw it right there, then make that correction now. As we continue to look at part A, it says after you've drawn it to show 28 hundredths, which we've done now, that's the same as 2/10, and you can see that we have 2/10 here. It's the same as 2/10 plus 8 hundredths, and that's true because I circled past the 2/10, and if we add 2/10 plus 8 hundredths, and again I would have to break these equal tenths up into 10 equal parts so that the entire thing would be 100 equal pieces like the question we had before. So if I were to do that, you would know that 28 hundredths is the same thing as 2/10 plus 8 hundredths. And we've done a lesson prior where we did expanded notation on decimals, and you learned that 2/10 is, or the 2 in the tenths place is 2/10, and the 8 in the hundredths place is 8 hundredths, and that you could break that down into expanded form by taking the 2 out, giving the value of that 2, which is 2/10, then taking the 8 out and giving the value of that 8, which is 8 hundredths because it's in the hundredths place, and adding those together. And they're also showing you that this expanded notation form is the same as 20 hundredths plus 8 hundredths. And why is that true? Well, you know I've said in the past that you can put zeros on the end of your decimals. They don't need to be there, but you can add them and it doesn't change the value. So in other words, I've told you before that you could add a 0 to this 2 and it will not change the value. It's still equivalent to 2/10, but we would read it now as 20 hundredths. And that's what this number is, 20 hundredths. But you can also go up to this number line and see that the value is the same, because if we were to divide each of our tenths up into 10 equal parts again, as I tried to do here, it's difficult to do here, but if we did that, we would have 100 total pieces. If we did that from the beginning to the end, there would be 100 total pieces. And if we counted how much we shaded, we would have counted 10 plus another 10 plus another 8, which when you total it up equals 28. So there would be 28 equal pieces out of 100. Now I'm going to ask you to do part B on your own, which is circle a new distance now to show 74 hundredths. So you're going to be showing that 74 hundredths is the same as 7/10 plus 4 hundredths, which is the same as 70 tenths because we're just putting a 0 on the end of the decimal, which doesn't change its value. We're just changing the 7/10 to 70 hundredths, and that's okay to do. And plus 4 hundredths, which is the same as this. So really, I'd just like you to pause the video and circle a new distance from 0 to 74 hundredths. Do that now. Okay, welcome back. And let's see how you did. We're supposed to circle 74 hundredths, yet we have a number line that doesn't show us hundredths. So what I want to do first is probably visualize the hundredths place. And I could just visualize it, or I could just make it a little easier to visualize by trying to do my best here to create 10 equal spaces in between each of my tenths, because 10 times 10 is 100, and this is not going to be accurate, but it's just for visual representation. You can see that we could divide this up into equal parts. If we could do that and divide it into 10 equal parts each time, we would have 100 equal parts. It would be easy to circle 74 of those 100 equal parts. And so as we go along, I want you to be thinking about that, because as we go, this would be 10 out of 100 here. And in other words, 1/10 is equal to 10 hundredths. And that can be proven because we could just add a 0 to the end of this number. As I've told you before, those zeros at the end of the decimals, they don't need to be there, but you can see that by putting a 0 at the end of the decimal, it doesn't change the value, because 1/10 is the same as 10 hundredths. And this would be 2/10 or 20 hundredths. And we could add that 0 to prove that. And this would be 3/10 or 30 hundredths, 4/10 or 40 hundredths, 5/10 or 50 hundredths, 6/10 or 60 hundredths, 7/10 or 70 hundredths, 8/10 or 80 hundredths, and we can keep going, 9/10 or 90 hundredths, or 1 whole or 100 hundredths. Now I'm going to circle 74 hundredths, which isn't going to be as difficult now, because I can see my 74 hundredths. I'm going to start at 0 and start circling until I get to 70, 71, 72, 73, 74. It should be just below or just before the halfway mark between 70 and 80. Somewhere right below the halfway mark. And what that shows us is that 74 hundredths is the same thing as 7/10 plus 4 hundredths. And this is why, because 74 hundredths, when we circled it, it's just after the 7/10. There's your 7/10. We went past the 7/10, so we're going to take our 7/10 and add to that 4 more hundredths. 1, 2, 3, 4 more hundredths. So 74 hundredths is the same as 7/10 plus 4 hundredths, which is the same as 70 hundredths plus 4 hundredths. And we got that from here. This is 70 hundredths, which is equal to 7/10. So there's equivalent decimals there. When you add zeros to the end of the decimal, we're not changing the value. It's still the exact same. Now let's take a look at number 3. I'm going to do 3A for you and ask you to do B and C on your own when I'm finished. 3A is asking you to shade the grid below to show, in A, to show 40 hundredths. And you'll recognize this is a hundredths grid, and there are 10 equal columns here, 10 of them, and there are 10 boxes in each one, so it's a total of 100. And so you could do this one of two ways. You could count 40 of them and shade them. You could do that. Or you could know that 4 tens equals 40. And so then you could just shade 4, in this case, 4 rows, and that would be a total of 40. Not too difficult there. That is 40 out of 100. 40 out of 100, or 40 hundredths. And that's how you read this decimal, 40 hundredths. This decimal should be read as 4/10, however, because as I've said many times, that we don't need these zeros. They don't need to be there at the end of the decimal. And so I prefer to take them off and make it a simpler number to read. And so 4/10 is also what I've shaded here. I shaded 4/10 because each of these columns is 1/10. And I've shaded 4 of them. Now I'd like you to pause the video and do B and C on your own. Let's take a look at number 4 now. Use a sketch of money, a bar representing 1 whole as we did above, or a number line also as we've done above, or 1 or more grids as you see just above this in question 3, to prove that each statement below is true. So now you're going to create your own representation, your own model to prove that this is true. So using one of the models above that we've used, we haven't used money, so I would stay away from the money part of it. But using 1 or more models as we've seen above, go ahead and do question 4, part A and B. And then take a look at question 5 and see if you can answer that question now after having done this page. And this will conclude today's lesson.